Hello everyone, my name is Marie and I'm doing my PhD project on this fish, and I'm trying to investigate the impact of global warming on Boreogadus saida using some genomic tools. So I just started, so I don't have any cool results to show you, but I will explain like how you can use genomics for sustainability purposes. So the main objectives of my PhD is to assess the genetic structure of the species. So maybe you're not very familiar with that. So I will start with a little bit of background. So in ecology, when we talk about a population, we refer to individuals of the same species that live in the same area at the same times and that can reproduce with each other. And scientists that are doing population genomic studies are in fact doing some comparison of DNA sequence at a large scale. And they are comparing the DNA of individuals from different groups. And we put like a threshold behind which we say that the sequence are too different or similar. And I put on the PPT two main scenarios so you can better understand and visualize what I'm talking about. So in the first case, we have like a Canadian group of fish and a Russian group of fish. And after comparing the DNA sequence, we conclude that they are very similar. So we have one big population. And in ecology, we talk about pentametric population. Whereas on the other case, after comparing the DNA sequence of the two groups, they are different. So we talk about two distinct populations. And this is really important for management issue. Because in the first case, you will have to consider your population as a whole, so you will have only one management plan, whereas in the second case, you will have to put in place two different plans that consider the specificity of each population. And in that specific case, it's very important because if you lose one of the population, you will lose a lot of genetic diversity, and it's really the last thing that you want when you're dealing with conservation. So in order to better understand, I will dive into my own project. So this is the main character of the story. So it's Boreogadus saida that we commonly name verticode. And maybe you're wondering what is so special about this fish that it's like seems kind of not very special, but it is. Is considered as a key prey item for the Arctic ecosystem, meaning that it has like a central role in the Arctic food chain. So we rely on amphipods and copepods that eat some ice algae, and it is itself consumed by some bigger marine mammals, such as seals and some whales, such as Boreogadus and mammals, but also some marine birds. So it has really like a central role in the Arctic ecosystems because it will transfer energy from the lower trophic level to the upper trophic level. So if you do care about the nice big mammals, you should also care about the conservation of that fish because like it's really important, and all of those animals will maybe starve if it tends to disappear. So for my project, I have some samples from Canada, from Greenland, from Norway, and from Russia. And so the idea will be to compare the DNA of all of those four groups and see how similar or how different they are. And it's quite exciting because it has never been done before at such a broad scale. So we'll have like a very good idea of what's going on with the population structure of this fish across the whole Arctic Ocean. And maybe wondering how we do it, so I won't go too much into detail. But usually, scientists that are doing population structure studies are using what we call rat sequencing. And so on the slide, the color refers to one individual, and at the bottom, you have like the entire genome of the species. And in that case, you see that you don't sequence the entire genome of the fish, so you lose a lot of information, which is kind of bad. So for my project, I decided to use whole genome resequencing technique. So I will basically sequence the entire genome of all of my samples. So at the end, I will have tons of data, which will probably be a bit challenging to deal with, to be honest. But it's going to be really interesting, and I hope that we will have some good results and we will have like a very strong resolution. So it's kind of cool. I am really looking forward to see what we will have at the end. But I won't stop here. I have two other objectives. And the second one will be to link the genetic difference that I highlighted just before to some phenotypic and some environmental variables. So the idea will be to look like at the causal effect of all of that. So for example, for the environment, I will take into account like the sea surface temperatures, and for the phenotype, I will take into account like some size of the fish or looking at the gill weight density, for example. And I will link all of that to the genome to see how they are linked and how they explain the difference between the different populations. And my last objectives will be to look at the resilience of the fish in terms of global change. And for that, I will be using some modelization tools. And the idea here will be to use a software that will allow me to play like with the migration rate and the selection strength at various loci to see how this change can impact like the population structure of the fish, and like to have an idea of the future of the fish in terms of global change, especially like in Arctic that is warming like at 4 times the global average. So the situation is kind of alarming, and I think it will be like really helpful for the management of the species, and it will probably help for its conservation. So that's it for me, and I hope that you better understand how genomics can be useful for sustainable purpose, and that's some of you find it too, and maybe we'll maybe do it later for your own research.